We'll continue a little bit with examples of set notation, and I'm going to use, let's see, this is example 6, page 313, and we're just going to use the numbers that are in that Venn diagram at the end there. So we have two subjects here. We have a class of 26 students, and they study history and geography. And the numbers that we want is, okay, 4 students study neither subject. We have 4 students who study both, and we have 12 students who study only history, and we have 6 students who study only geography. So what does it mean then when we say the intersection between A and B? The intersection. Well, it means A and B. So we could translate that inverted U sign, the intersection, as and, because when we look at this, what the intersection is, it's this area here, right? And it's obvious that this is both H and G. I suppose I should have written H and G instead. So H union G means H and G. And this is the only area in the diagram that contains both H and G elements. So these 4 students, they study both history and geography. Now, if we look at union, the union of H and G, what does that mean? Well, that means, it's either an element of H or an element of G or an element of both. The union is everything inside the 2 circles. So this is the union of H and G. An example of complement. If we're talking about complement to H, what does that mean? Well, it means not H. So anything that isn't H. And if I want to color that in, this is the complement to H. And combining notation is not a problem. What we do is just, if I write G, okay, let's have a look at the intersection of G and H, but we want the complement to the intersection. So this we translate as not the intersection of G and H. And that looks like this. Okay, so we don't want the intersection. We want everything around it. And that includes everything outside of the 2 sets as well. So the rest of the universal set. Not the intersection. So we color in everything except the intersection itself. We could also express something more complex, like G, the union of, the intersection of G and not H. So the intersection of G and not H, that would be the set that contains G and not H at the same time. Which would be, okay, we want G, but we don't want H. So this is the intersection between G and not H. And I'll finish with an example of the conditional as well. And we phrase that as a question: given that a student studies history, what is the probability that she studies geography? So a lot of the tasks will be to translate English into math. And this is going to look like, let's see, so we want to find the probability that a student studies geography, given that the student studies history. So the given part comes after this line here. So the probability that, given that a student studies history, what is the probability that she studies geography? Now, this is equal to the number of students in the intersection of H and G divided by the number of students in the set history. Now, the reason for this is, okay, we're looking at history students. So given that a student studies history, we look at all the history students. What is the probability that she studies geography? Those who study geography are these 4. So out of these 16, it's these 4 who study geography. And that's the intersection between H and G. So we take the intersection and divide that by the number of students in the whole set. So we're sort of pretending that H is the universal set for this problem. And so that's going to be 4. You have 4 people in the intersection, and we divide that by 16. Another simple way to phrase this is to ask, okay, how many, that's many, yeah, sorry, how many history students study geography? How many history students study geography? And we would answer 4 out of 16. And you've already learned that, okay, 4 out of 16, this is how we write fractions, and we translate this fraction line as out of. Very important, so try to remember that. I'll just put a red marker around that, okay? Okay, great.